Let's look at it. So, -3 divided by -1. Oh, -3, whatever. Oh, whatever, -1. Oh, golly. I think it, so Emery brings to my attention a mistake. I think I said the right thing and wrote the wrong thing. So this one going back, this one where I wrote negative, that's not right. There should have been -3 because it's 3 divided by -1. So this should have been a -3. Yes, thank you. Yeah, so next time when, no, don't wait. Don't wait 2 whole problems farther. Raise your hand and say, I got a different answer. Don't wait. Okay. All right, so we want to find I sub x, this one. So the first thing we need to do is determine how many extraordinary nodes, and so how many equations we're going to write. And I think you guys should write them. So how many extraordinary nodes do we have?
3.
Do we agree we have 3? 1, 2, 3. So let's go ahead and label those A. I'm going to label this B. Actually, use a different color. Blue. C. Do I need to write a node equation for all? Well, and also ground, obviously, but we're not worried about that. Do I need to to write a KCL for all 3 of those?
No.
No, why not?
We know B.
We know this one. So if you know it, there's no reason to write an equation for it. You already know it. Okay, so if it helps you, go ahead and write 12.3 right there just to remind yourself you already know that one. So that means we need to do KCL at B and KCL at C. So go ahead and write those out. And then we'll double check. Check my work this time. Don't wait for the moment. Is that what you guys got? If it helps you to draw the current arrows in the beginning, or however long you need to, that's fine. Importantly, at B sub B, there are only 3 branches, so 3 terms. At B sub C, there are 4 branches. 1, 2, 3, 4. You have to count them all. So this one is fine. This one is negative because the definition is the other way. This one we have to go all the way back to here. So B sub C minus the voltage on the other side, 12.3, divided by 5. So just because it's like not staring right in front of you or not going down the ground, don't worry about that. This is just a process. You just apply the process and don't worry about things too much. Is this ready for matrices? No, why not? Now I've got 2 variables, 3 unknowns. We have a problem. So what you would like to do is write I sub x in terms of one of your variables. So I sub x is this one in this direction. So how can I define this I sub x? It's current through a resistor, so it's the voltage on the first side minus the voltage on the second side divided by 10. And that's because this I sub x is predefined for us. I don't get a choice on that. So up here I can write I sub x is equal to 12.3 minus b sub b over 10. Oops. That needs to get dropped in here. Okay. So, so do we want to complete this one, or is this the hard? I mean, I think at this point, my inclination, this is the hard part. Once we get to here, it's just a matter of algebra and matrices and crunching numbers. What's that?
Let's say what the answer is.
Yeah. Well, so what I will actually post the entirety of the answer. I just don't know that we want to crunch through all of that in class. So yeah, I will make sure it's posted so that you can check it. But this is the hardest part. Once you get to here, it's just crunching out the numbers, right? So importantly then, so for the final answer, we're going to get, so squiggle, 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 magic. We're going to get for an answer, and I'll fill that in. V sub 1 is equal to 3.8. 3.8 exactly. And V sub 2 is equal to 5.8. So I will give you the rest of the in-between part. The reason I wanted to get to this is because is this our final answer? No, but we know everything. Once you know all the nodes, you know everything. So now we just come back up here, and actually if you think about it, in this case, we already have an equation for I sub x. We even already wrote that out. So I can just plug everything in. So I can come down here and say I sub x is equal to 12.3. Oh, sorry. Those are not 1 and 2. Those are B and C. Sorry. Change the numbers. So B and C. So minus 3.8 divided by 10. So 0.8 factors. So importantly, it's a process. You identify the nodes, you write your node equations, you crank it through a matrix, you have then define the entirety of the circuit. Then you go back and figure out what you're trying to find. And so yes, we ignore, to Todd's question, we ignore any predetermined, is it Todd's? I'm not sure who it was. If this is already defined as I sub x, then that's fine. We're going to come back to that when we go define it later. For the purposes of KCL, out and out. That's the process. Then we go back and find out what we're trying to find. Is that all right? Okay, so.
And this will sort things out, right, and tell us what the true current directions are in different parts of the circuit, because it's almost really, really hard to tell by looking at them sometimes.
And then we're quickly getting to circuits that are complicated enough you can't look and tell. That's exactly right. Yeah. So yeah, so this, once you know the node voltages, and next time, once you know all the mesh currents, you know everything. All right, so let me give you one more. We have to address one more piece. I'm going to come over here. There is one. I wanted to do this one next. Let's talk about this one before we do it. Let's just talk about it. If I wanted to do KCL here, oh, I'm sorry, I had the other one up. We're going to come to that one. If I wanted to do KCL here, how many branches? 1, 2, 3. B sub 1 over 1, B sub 1 minus B sub 3 over 2. What's the current through there? The voltage source. Do we know what it is? Is there any way to know? So I can't do this one the way we've been talking about doing it, right? Because I can never know what this is until I know what the rest of the circuit needs from it, which is what I'm trying to find. So chicken and the egg. So here is, fortunately, we have a solution for that, and this is called a supernode. And so if you think about what the problem is, V1 and V2 are not actually independent. Do we agree that's true? If I know V1, V2 is just 6 volts higher. So they're not actually independent variables. So we call this a supernode. And a supernode is anytime you have two nodes, by which I mean extraordinary nodes, connected by a voltage source. It means KCL is impossible at either one. So that means that really the node voltages are not independent. So here's our process. We're just going to tweak our process a little bit. So the first thing is, we're going to go ahead and label the nodes like we have been. So label them individually, V1, V2, VA, VB. And then we're gonna write KCL equations, treating the whole double node, you can think of it that way, as one node. So we're going to write KCL equation, write one KCL equation, or I'm going to write it as, we'll just say double node. Using the appropriate voltage. So an example will make that clear. That means we're going to have one equation and two unknowns. We have a problem, right? We can't, that's not enough to solve it. So what we're also going to write then is what I call an auxiliary equation. That shows the dependence of the two nodes. So I know that V sub 2 is 6 more than V sub 1. So I can write that as an equation. So so to define the relationship between the node voltages. And then solve as usual. Now we have two equations, two unknowns, crank it out, and so on. So solve as usual, same process. Okay, so let's do an example. And then I have a comment about the example. So this is the one we're going to start with. So we see three extraordinary nodes. 1, 2, 3. We see that two of those nodes are connected by a voltage source, so they are not in fact independent. So this is one big supernode. So again, I'm going to change these into VA, B, and C, just because that's what I prefer. VA, B, and BC. I'm going to write KCL at V sub C first, because that's just a regular old node. Right? There's nothing different about this one. So KCL at node C, V sub C. We can keep in all the 4 Ks. We just know that if we turn them into 4 instead of 4K, we're going to, instead of dividing by 4,000, if we only divide by 4, that's a milli. So I'm going to keep in the 4 Ks, but know that you can also drop the K and just insert a milli in your current answer. Because 1 divided by 1,000 is a milli. All right, so we're going to have V sub C over 4K plus V sub C minus V sub B over 6K plus V sub B minus V sub A over 2K. That's nothing new. So notice that we use V sub A, and we still define V sub A and V sub B. That doesn't change. We still define that. Now we gotta treat, yes?
You mean write V sub C for the third one?
Yes,
Yeah.
that should be C, thank you. Yes, 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 thank you. Add that back in. Okay, so now we gotta treat the supernode. How many branches are coming out of the supernode? 1, 2, 3, 4. So we treat this as one big giant node together, and I count 1, 2, 3, 4 branches coming out, so 4 terms. So we're going to do KCL at node AB. I'm going to start down here. What is the current through this one? V sub A minus 0 over 1K. I know what that is. V sub A over 1K. This one is V sub A minus V sub C divided by 2K. This is part of the node, so I'm not worried about that. That's not a branch that I'm considering the node all one node. So now I'm going to hop over here. What is the current through this branch? In this direction, V sub B minus V sub C divided by 6. And then finally, V sub B minus 10, right? Because this is 0, that means it's 10 right here. So V sub B minus 10 over 5K. So when I say using the appropriate voltage, I don't think there's one, I don't know. Bring it back again. This is not going to be ideal. So when I say using the appropriate voltage, what that means is here, this is really from V sub A. And this one's really V sub B minus V sub C. So just use, but now what do I have? 2 equations, 3 unknowns. So this is where this auxiliary equation comes into play, because that gives us the one more equation we need. So what do we know? We know that V sub A, I climb up through 6 more volts, so V sub A plus 6 is equal to V sub B. So I can write V sub A plus 6 is equal to V sub B. It is. Yes, we can even label that auxiliary. That's kind of my word. I don't know if anyone else uses that. Just FYI. So now I have 3 equations, 3 unknowns. Write it in standard form, link it through a calculator, spit out the answer. And so if I'm looking for V sub x, is that really trivial to find once I know VA, B, and C? V sub x is V sub A minus 0, it's just V sub A. So this is really easy. So in the end, V sub x is just equal to V sub A. So again, I will sort out through all the equations and write that out. So importantly then, you can have supernodes and regular nodes in the same circuit. You identify a supernode because as soon as you go to write KCL for this, and you're going to try and find the current through this, you should say to yourself, but I don't know what the current is through a voltage source until I solve the circuit. Chicken and the egg, you can't get one, so you can't do it that way. So that's how you know that you have embarked on the wrong path and you need to back up. Yes?
So do we just get it into terms of 2 variables and then put it in the matrix C?
I think 3 variables. I have VA, B, and C. 3 equations, 3 unknowns. This one just won't have any B sub C component to it, so you put a 0 if it's missing a variable. Yeah. Okay, so what time is it? All right, so let's come back to this one. And once again, let's just set this one up. So take a moment and set that up. Again, I don't see any other way, aside from one of our processes, to do this. Right? I'm not saying, it's is far too far. So this is perfect. I will say that one of the things we talk about when we're trying to evaluate whether to do node analysis like we did today, or mesh analysis like we're going to do next time, is how many equations, how many unknowns, well, how many equations and unknowns, and then how hard is it to find the thing you want. So here I count 1, 2, 3 nodes that I don't know. So I'm going to have 3 equations, 3 unknowns, and that's how hard it is to find the thing I want. Not very hard at all. So when we're trying to analyze what's better, node or mesh, that's the extent of what we need to know. So here we know that we've got 3 equations, and we know that I sub x is easy to find.
Yeah.
Okay.
Yeah.
So do we know any of the node voltages? Do we?
-4 volts on the top, or
From
Coming in at the top as well.
negative from
oh,
here.
never mind.
We don't actually, you only know a node voltage if you can count from ground to where it's going, so.
So if we made ground like the top left corner, then we know that one.
Yes, correct.
Is that
Right.
another technique?
Yeah, don't do that. Yes, you could, I recommend not doing that.
So make everything else harder.
Yes, but so importantly then, let's identify some things. When I want this current, I need to know the voltage here and here. So if you want to, just go ahead and, let's use this color. No, this one. This voltage here is 2 volts, because it's 2 volts higher than 0. What is this? I'm never going to need to know here, that's easy. 3 volts higher than 0. To find the current here, I've got V sub 1, I need to know this voltage here. What is that? It's not 4, because that would be 4 down to 0.
The supernova?
No, because supernode has only a voltage source between, that's only it. It's 4 volts higher than what?
Then whatever.
Then V sub 3. So this is really, the best I can do is V sub 3 plus 4. That's what's sitting right here. That's the best I can do. But that's okay, because V sub 3 is one of my variables. All good. So I encourage you, in a case like this, this is the easiest way to make sure that you get the 4 plus or minus the way it's supposed to be. Yeah.
So for the first step on supernode, it should say 2 nodes connected by only a voltage source?
Yes, correct. Thank you. Absolutely. Only a voltage source. Yes, because as soon as you put in a resistor, then it's not that anymore at all.
Should you define it in terms of like V1's voltage instead, in that resistor right there? Or would that be nonsensical?
Yes, I think you could. I think you'd have to. No.
It just wouldn't be helpful.
No. Kind of, but maybe you and I can look at that individually. I think this is the simplest way to think of it. It's
How
just-
did you know that? That's what I get in trouble with, is I'll come up with some complicated
V
formula.
sub 3, if I was going in this direction, I encounter 4 volt rise, because I come in on the negative side, so it goes up. So I start at V sub 3 and I come up 4 more volts, so that's how I'm there.
Right.
Yes, so I would say so if the current coming out here would be V sub 1 minus that whole thing, through parentheses, divided by 2. All right, so let's go mirror. All right, let's write them out real quick. V sub KCL at V1. So I get V1 minus 2 over 0.1. V1 minus V2 over 0.5. V1 minus this whole thing, keep your parentheses so you get that 4 in the correct wording, over 0.2. I have done this a lot of different ways, and this is hands down the simplest way to think about it. All right, so that's V sub 1, V sub 2. So I'm going to have V sub 2 minus V sub 1 over 0.5. V sub 2 over 0.1. V sub 2 minus V sub 3 over 0.5. You should be able to get to the point where you're ripping them off about that fast, because you're really just saying this minus this over that, this minus this over that, this minus this over that. And then our last one, V sub 3, and again, I'll post all the actual solutions. So V sub 3 minus, ooh, interesting problem here, yeah. Let's think about it this way. The current through this branch is the current through that resistor, which is this voltage minus that one. The current through this whole branch is the current through the resistor. I don't know what the current through this is. That tells me nothing because it's a source. It is. That doesn't tell me anything. So I need to concentrate on the resistor. The first node minus the second one divided by the resistance. So V sub 3 plus 4. That's the first that I encountered, minus the V1 over 0.2. And then the rest is easy. V sub 3 minus 3 plus 1 plus V sub 3 minus V sub 2. Now, this is where I really wish we had whiteboard for this. So again, I will post all the completed solutions with all the matrix numbers so that you can practice that. But that's something that, if you find that you're having trouble with the matrices, please come see me. So, because sometimes it's easier to just sit one-on-one in front of the calculator and work it out. Which one? This one? Because when I'm looking at that branch, the current in this branch is the current through the source, which is exactly the same as the current through the resistor. I always have the current through the resistor. The voltage on the near side minus the voltage on the far side divided by the resistance. So this just doesn't tell you anything except any of this particular voltage to be different. I do not know how well these, I don't know if this videoing is going to work well. The lighting is bad, and maybe.